In today's video, we'll cover a foundational concept in reinforcement learning training code, and that is that of async functions. So by the end of this video, you have a better understanding of the concepts behind asynchronous functions and how they are relevant to building a rollout engine. So we'll start off with covering some of the key concepts in async functions, and then we'll move on to a live coding example. So to start off, let's recap what goes on inside a reinforcement learning training loop. So in reinforcement learning, we need to generate multiple rollouts for a given prompt. So we send this prompt into an inference engine, we generate the rollouts, we compute the rewards and use this to update the policy model. So the slow way to generate these rollouts would be to do this synchronously. That means we pass in the first prompt, we wait for it to generate a rollout before passing in the second prompt, and then wait for that, and then before passing in the next one, and so on. So this is very slow because each rollout takes quite long, and so we have to wait for each rollout to finish before we can generate the next one. So what we actually want to do is actually to generate these rollouts in parallel. So we're going to pass this prompt to the inference service in parallel and generate multiple rollouts and then be able to collect them back. So the way that we can manage this is through async functions. So usually we can also use multiprocessing to execute things in parallel, but we actually do not need the extra overhead to spawn extra threads and processes because we're just making a LLM API call. So a better way to do this would be to use async functions. And the key idea is that when we are calling a function, we want to be able to pause it while we are waiting for it to call other functions as well. So the way that we can do this is to specify coroutines. So a coroutine is a resumable computation that can suspend its execution and later continue from where it left off. So this is the first concept that we are covering in terms of like asynchronous functions. And the way that we can define these coroutines would be to use the async def function. So for example, if we have this generate function which we want to specify a coroutine, so for example, we would call generate, which would call a LLM API, and then that will take a while. So we want to pause it and be able to call other LLM API calls. So we would define the generate function with async def. Finally, once we have defined the function and we actually want to allow it to pause its execution, that's where we can use await. So await allows us to pause the current coroutine until the operation completes, and then it will allow it to continue from where it left off. So when we're actually executing the generate function, we might call this await function. So the way to actually schedule this coroutine to run would be to use this create task function. However, here you can see is that we are actually running multiple create tasks. So if we want to do this in parallel and like one shot, then we could use the getter function. So the getter function will allow us to schedule multiple coroutines concurrently, wait for all of them to finish, and then collect their results. So to recap the concepts of asynchronous functions that we have covered, so the first one is that of a coroutine. So a coroutine is basically a resumable computation that can pause its current execution and later continue from where it left off. And the way we pause it is to use the await function. And the async def function allows us to actually define these coroutines. So finally, to start the main event loop, we will use async io.run. So this will start a coroutine loop and will run a coroutine function to completion. So to start a coroutine function and schedule it to run concurrently with other coroutines, we would use the create task function. Furthermore, if we want to schedule multiple of these coroutines in one shot, we could use the getter function. So this will wait for all of them to finish their computation and then collect their results. So two other concepts which we will cover in other videos is also the lock and the semaphore. So the lock prevents multiple coroutines from executing specific section of code at the same time. And the semaphore would just allow us to run multiple of these coroutines but set a limit to it. So it will allow at most n coroutines at a time to enter a section of code. So for example, you can imagine in large RL training runs, we might have tens of thousands of LLM API calls. And we might want to restrict the number of LLM API calls that we can run asynchronously. And with that, we will use the semaphore. So now we'll move on to a live coding example where we show how we actually use asynchronous functions in the context of rollouts. So here we have a basic template. So as you can see, there's nothing in this script. However, we'll cover the basic steps. So first we'll define a mock LLM API calls. We would process the inputs, which is prompts, and then we'll run the synchronous rollout setting, and then we'll compare it with the asynchronous rollout setting. So we will also show how we do this using create task and also the getter function. So let's start by defining the LLM API calls. So first, we will call the synchronous LLM API, and it will take in a prompt. So what we want to do is mock the time it will take to generate the rollout. So we'll say a random time. So this will just be random.random. So this will generate a random value between 0 and 1. And then what we want to do is actually to call time.sleep. So this is the time it takes to run the rollout, and then we pass in the random time, and then we return our output. So we'll say return message, and then just pass in the random time. So let's see that this is working. So we'll say print, let's use the logger.info synchronous LM API, and then we say prompt 1, for example. So let's run this. So we say Python async tutorial. Yeah, and here you see it is returning the output after waiting 0.38 seconds. So now let's specify the asynchronous LLM API as well. So remember to, when we are defining a coroutine, we have to use the async def function. So we'll say asynchronous LLM API. Again, this will take in the prompt. So this will look very similar. So we'll just copy it over. But instead of using time.sleep, we actually have to use the await async io.sleep. So this will allow us to specify the asynchronous LLM API. So now let's test this. So we would say async io.run asynchronous LLM API prompt 1. So let's run this. Yeah, and here you see it also returns the output. So both our mock LLM API calls are working. So now we want to create a mock function to generate prompts for us. So generate prompts, and what we want to do is take in the number of prompts as well as the number of generations. And so we'll say prompts equals prompt I for I in range num prompts, and then we would expand it out because for each prompt we are generating group of rollouts. So we'll say repeated batch equals to prompt for prompt in prompts. So what this is saying is that if I have some prompts P1, P2, then I will generate groups of the prompts, so I'll repeat them. So I might have something like this. And then we want to return the repeated batch. So let's test it out. So we'll say, let's specify the number of prompts we want as 2 and the number of generations we want as 2. And then we'll say the repeated batch will be generate prompts. So we'll say num prompts, num generations. And let's print, okay, let's use the logger, repeated batch. So if I call this again, here you can see that it generates the prompt. So this is exactly the setting, prompt 1, prompt 2. Then we generate 2 of prompt 0 and 2 of prompt 1. Okay, so now let's test out our synchronous rollout setting, right? So we'll say def generate synchronous rollout batch, and then we'll pass in the prompts. So we'll have results, and then we'll say for prompt in prompts, result equals synchronous LLM API, and then we pass in the prompt, and then we append this to the list, and then we return the results. Yeah, so let's see how long the synchronous call would take. So we'll say start equals time.time, n equals time.time, and then we'll log it. So we'll say time taken to do synchronous generations n minus start. Yeah, so we'll say synchronous generations equals generate synchronous rollout batch, and then we pass it the repeated batch. And then we can print out the synchronous generations. And now let's see. So here you can see that it's actually taking a while. So the synchronous generation is pretty slow, but you can see that for every input that we passed in, we managed to generate the output. So this is the synchronous generation working. So now let's run it for the asynchronous case. So we will say, let's copy this. So we'll say generate asynchronous rollout batch. And remember, we are specifying a coroutine, so we have to say async. So here we'll say task. So create task will actually allow us to run the asynchronous LLM API function. So we'll say for prompt in prompts async IO dot create task. So this will allow us to run the async LLM API call in parallel. So we'll see this. So and then we will specify this as task, and then we'll append it to the task. So this would start the async LLM API call, but now we want to collect the results. So we'll say results equals await task for task in task, and then we're going to return the results. Yep, so this is using the create task API. So let's do the same for asynchronous. So let's copy this whole code, and then we'll say the asynchronous generation. So generate asynchronous rollout batch, and then we have to call async io.run to run the main coroutine. And so we'll say asynchronous generations, time taken to do asynchronous generations. Yeah, so let's see. So here you see that the asynchronous generations were actually a lot faster. So just like almost half the time it took to do the synchronous generations. And you could see that it is currently capped to around how long the longest rollout took to do. Yeah, so remember I said that if we want to run multiple coroutines concurrently, we could use the getter function. So here we'll show. So this is using the create task, but actually we can simplify the code. So instead of calling all of this, we could use results equals async io.gather, and then we'll say star asynchronous LLM API prompt for prompt in prompts. Yeah, and let's run this again. Okay, let me check this. So okay, so we need to await the async io.gather. So let's run this again. Yeah, and here you see that again the asynchronous functions ran a lot faster. So to see a bigger discrepancy, let's increase the number of generations and the number of prompts. So here you'll start to see that the synchronous generation takes a lot longer, while the asynchronous one would still be almost equally as fast. So let's run it again. Yeah, and here you can see that the synchronous is actually taking really long now because we have multiplied the number of prompts by 4. But here you see that asynchronous generation is really fast. In less than a second it completed, while for the synchronous case it took 9 seconds. So yeah, this covers the concepts of asynchronous functions and how we will actually use it in the context of building a rollout engine. Hope you enjoyed the video for today and look forward for the next one where we will start to really explore how to build a production gate rollout engine.